All right. Hello, my name is Quang, and in this video, I will show you my project to object detection. So, what is the problem? Well, I have to use the C programming language to detect dots of face and draw a dynamic box with the two given inputs, templates, and images. So, how about approaches to solve this problem? Well, first, you need to convert all RGB to gray colors. We have to apply the average span method by transforming 3D channel to 1D channel image. More specifically, you have to like divide the red, green, blue values by 3 to get the grayscale, and you also need to create two functions gray conversion. In this function, you will have a lot of for loops to compute, yeah, and to compute and run through the image and like transform the 3D channel to 1D image. For all gray conversion, its function includes templates and the given images. Next, you need to calculate the cosine similarity and slide images. So what I mean here is that you have to use this formula to to compute the cosine similarity. I mean, uh, we use cosine similarity to detect. The similarity between the image and template and how it is close to match with each other. If the cosine angle is small, it will detect the face and draw a drawing box. Yeah, and you also need to slide images from, and you have to use for loops. Yeah, to run through the image where templates match with the where where to move to the section or domain that template would match with the image. Yeah, and the final step is to draw a bounding box. So after full finish on the above given step, you need to compare the gray image and the gray template to detect the face and draw a white bounding box. All right, so thank you. And now I'm going to show you my code. So you can see here the project 2, and I initialize um, 7 folders, but actually um, I'm just use only 6 folders. So let me show you. So the folder symbols I store the given inputs, yeah, like this, and there is the templates. There's one templates folder where I store the templates. So my mission is my duty is now to convert the samples and templates into the great ones, and I initialize what a C folder, a C file, yeah, to compute the gray, and I transform the 3D channel image to 1D channel. You know? So as you can see here is the function gray conversion, and I initialize a variable here, image, to read the path and load the samples. So I create some variables here: red, green, blue, total, and average. Total is the total values of red, green, blue. Yeah, as you can see, and then I will calculate the total values. And the final step is to transform the 3D to 1D by divide all the values by 3. And finally, I will return gray. And this function will get the gray value for the picture. And this one is just used for the the template, I mean the RGB template, and it will compute, the template into the gray one. So I run a for loop from 0 to 63 to load approximately 62 images, and I will use sFreeNAV to to load um, to load the the samples path. Yeah, you see. And if this variable is null, it will print error in loading image. Otherwise, it will print the gray images from 0 to 62, I guess. Let's see. Yeah, exactly. And the final step, I will call a function here. Yes, and I will print a sample with high channel and the same with template. If it's successfully done, the output will be on the screen, and I will show you the output here. Just wait a minute. I got so long. Yeah, congratulations. Yes, and you can see sample with high channel template. Oh yeah. And for the next step, I will move to the color conversion. You see? And I just create some libraries here, like the same the previous one. And I will call a function to create an array. Yes. And of course, I need to compute code size similarity first, and slide the image. So I just initialize some values here to slide the images. So you see, with these variables, I just initialize the width, height. I mean the width height of the sliding images, and this is the numerator of vector x and the numerator of vector y, and I will show you. Just wait a little bit. Yeah. So the idea is really simple. For the denominator, I will compute the multiplication of vector a and b, and compute the sum of it. Next, I will divide the denominator into two sections for the vector a and vector b. I will calculate square root of vector power 2. I mean the sum of square root of the sum vector a power 2 and a sum and the square root of vector b power 2. Yeah, so the code is right here. I will run the for loop from 0 to the height limit. Yeah, and I will initialize the denominator x and denominator y here. Because I need to update the for loop. Because if I take these variables outside the for loop, it does not work. Yeah, and inside the for loop, I will create the two for loops again to compute the code size similarity. Yeah, for the numerator, this is the vector a and the vector b. I mean, it's the template. Yeah, the template multiplied by the image. Yeah, for the vector x, I can also compute the sum of the dot product. Yes, the dot product of template and template. Then for the image, I think in this slide, just for the vector x, yeah, to be more exactly. And for the vector y, I will compute the sum of power, image power 2. And when I run outside the loop, I will mm, I will take the square root of denominator x and the denominator y. Yes, and you know to solve the problem that we cannot track the objects, I need to update the loop in the draw function. So in with the draw function, I will set the threshold to 55 to make the color of the box white. And you see here is the derivative is a bounding box with a white color, yeah, with a value 255. Yeah, but if you want to set the values for RGB colors, you just only to change a little bit, and I mean we can set the value like RGB like 255, or red is 255, green 104, or blue is 6. Yeah, it's totally fine. And when the loop is done, the function will print the new image. And if it runs successfully, new image is saved to the path. I mean the folder. Yes, and I think that's all. And finally, in the main function, I also need to call the path here. Yeah, the template gray, where it is gray, the template gray from 1 to the 62. Yeah, from the above. I mean, from a given C file. Yeah, and I will load it from its path. If this variable is known, I mean this variable cannot load the images from the template gray folder. It will print fail to load template, and then it will exit. I mean it is totally bad. If you I mean this program fails if it does not load the template, and your program may have some problems. And next, I need to initialize the width height channel of the image. This one is for the templates. Yeah, understand. If it does not load any images, it fails to load the sample. Yeah, and if successfully, there will be the height, widths, or channels of the samples and templates. For the operation name, the results will be loaded in this folder, results gray. I mean the folder with a template and images with the about box. Yeah. Wait, just wait. Yes, this one. Yes, and of course, I will need to load the images. I mean, to run a folder from 0 to 63, to below 63, to run approximately 63 images. And I also need to use SPNF to load the gray images and the template to compare them together. If it matches, I mean the cosine angle, yeah, is small, is small, yeah. I mean it matches, and it will draw a bounding box for sure. And the results here, right here, will be right there, and you will get the results in this folder. So I need to just the last step. I just need to call the compute cosine similarity function and use the load temp, image gray, some variables like width height, yes, the file, yes, yeah, you can see right here. Is some values I need to assign, and the last step is to load the template. Alright, I think that's enough for my video. Thank you for watching.